So in this video, we're going to start on our gameplay system. Before I do that, I just want to cover off on some things that we'll be using for the gameplay system. So the gameplay system is going to rely heavily on the use of delegates, so I thought I'd just cover a little bit about delegates and how we're going to use them. So delegates are a method for implementing what's called the observer pattern. So you can look that up. It's just a generic coding practice that they call patterns. There's a whole bunch of them, and delegates is an observer pattern. So what's the observer pattern? The observer pattern is where an object maintains a list of dependents. So the object is generally called the subject, dependents are generally called observers. It sets up what's called a one-to-many relationship, meaning that you're going to have many observers subscribe to one subject. And these observers are subscribing to the subject so that they can be informed about some sort of state change or an event that happens. You often hear delegates referenced to as events, and I think Unreal even may still have it in. Well, I think maybe they're phasing it out, but they had a delegate set up where it was called events. So when an observer registers with a subject, it's different. You'll hear it referred to as binding or being bound. So the delegate's bound or something like that. And you can see an example there of two of the delegates being assigned. The observer will define what it wants to occur when the notification comes of the state change. So in that example there, they're both executing a function when the subject notifies them of the change or the event. And the subject notifies the observers through what's called a broadcast. I hear it referred to as executing the delegate or an execution. But in Unreal, the actual function is called a broadcast. You can see an example there on the multi-group command execute. And a broadcast can include variables. So you can see there it's passing the actual command variable, whatever that is. You can pass whatever variable, even object pointers and things like that, any variable. So there's two main types of delegates in Unreal. There may be others, but these are the two main ones. So there's a multicast delegate, which mostly is just used in C++, and the only difference really is that it allows static binding. So that's like to a static class, means you don't have to have an instance of the class to execute that binding. And then dynamic multicast delegates, they're designed to be integrated with blueprints, and they can be bound to blueprint functions. So if you're going to be implementing, delegates from C++ into blueprints, you want to use the dynamic cast delegates. So another thing I just want to cover is the concept of left value and right value. And you may see these in some errors you get sometimes. The rvalue and lvalue terms come up. And I was always confused about this when I was learning what's an R value? What are you talking about R value and L value? So we're actually going to use an R value in the with our delegates. So all the R value means is it's the right value of a variable declaration. So if you have a value called int, a value type of int, and it's called value, and then it's got the equal sign and it's equal to 21, then 21 is the R value. So it's that temporary unnamed value for that instance on the right side of the variable assignment. And it's temporary because it needs to be immediately used, or it's going to turn into an L value because we assigned to that variable that we just called value. And then L value is the left side of that variable assignment. So it's generally an expression that refers to memory location. It'll point to a physical object or variable, and it's persistent, so you can modify it over time. It's like every variable we assign in, like if you assign a variable in a h.h file, then that is an L value, and it's you can access it at any time and later on. Where R values come in is they're often using something called move semantics, and move semantics is used to efficiently transfer ownership of a resource without copying it. So it's only temporary, so you have to do this straight away, but you can change who has ownership of that value. We're going to use move semantics to allow us to execute delegate for a single observer, or combine that observer into the main broadcast. So if we have a delegate that has its broadcast list, so we have a subject that has a broadcast list, and then the observer comes in, and as it comes in, we say, okay, do we want to add this observer to the list, or do we just want to tell that observer to execute that delegate straight away? So by doing that, we can execute the delegate to a single observer, or we can add it to the list and call it for everyone on that list later on. So there's some complex topics there. I just thought it's worth putting out there. The more you hear it, the more you get to know it. But now we'll move on to setting up our game phase system. So moving on to our game phase system. The game phase is just a series of stages that we move through in the back end of the game. So we'll transition from each phase. And then the reason why we need the phases so we can handle different actions required to prepare our game at different times. So it'll allow us to display different things at different times and then transition through the game just in an orderly manner. And the phases that you need is going to depend on your game type, really. However, the system we'll be designing here is completely flexible. It'll only use the phases we need for a particular game type. So we're going to be using our game data to determine what we need and what we don't need. And then essentially the things that we need to load will register with the game phase system to say, hey, I've got a task I want to complete in this game phase. And then if there's the game phase system will check, is there any tasks to be completed in this phase? And if there is, it'll wait until they're completed and then it will go to the next phase. Whereas if there's no tasks to be completed, it's just going to skip straight to the next phase. So this eliminates the need to statically define what phases you're going to go through. You can just have a general list of phases that you're going to need, and you don't need to add or remove phases because phases that won't be used will be skipped in any case. So I think we'll start with setting up our enum for just our game phases. I'm going to create that in a separate H file because that's how I usually set up enums and structs, so I can just include that file in any one file. I don't have to include the class if I don't need to. So we're going to create, in the data file, we're going to create a file. I'm going to call this RTS core data types.h. Add the pragma once, which if you're not aware of what that means, it means to only load this file once, class once, if it's included in multiple places. Pretty sure that's what that does. We'll need a generated reference here, so I'm going to include the name of the file, RTS core data types, do that. But then it doesn't need to be the .h because that's referencing itself, it needs to be the generated h. So now we're going to declare an enum. And it's going to be, I'm going to prefix my enums with the plugin name as well, just so there's never any overlap between naming between the plugins or the project. So it's going to be RTS core, and call it game phase date. So we're going to have a few phases here. So the first one is I just want a generic phase, so I'm just going to call it loading. Generally when you have an enum, you should have a value that's nothing, like it's not that thing. So it's like a default value, so you know it hasn't been set or something. So that's what loading will be for us here. I'm going to have new game. You can call these whatever you like. This is just what I've decided. So load game data. I probably should describe what these are. Put in, this is the default phase. This is just indicating we've just started a new game. Yeah, load game data is pretty self-explanatory. For the next one, initiate. So we've sort of done all the pre-loading of so basically we've loaded the game data. But now here, this is where we want to create menus and do things. Create menu, host session, things like that. I have another one called setup, reference to like game setup. So we may have, this is more like a lobby before the game. Apply settings, or some sort of setup UI. Now we'll have sort of going into the game phase now. So we're going to have a preload phase where we load the actual game data. So we'll preload assets or data required for this game type. And then we'll have a pre-gameplay, which is then we can use that loaded data to spawn anything that we want to spawn, like units or players, and it'll be just any pre-configuration prior to the actual game starting. So let's call it that. Let's call it pre-configuration required before gameplay. We're going to have our actual gameplay then. So it's just where the player's playing the game. Gameplay. Then we'll have post-gameplay. So post-gameplay, you might want to show some sort of end screen or stats page or whatever. And then we're going to have a abort phase. So this phase, this phase will be such as when you like just press escape menu and exit the game. All right, so that's our phases defined. Go back to our game state. So the first thing we want to do is have a property here, replicated. That is our game state. So we'll make that replicated using. We'll have that on rep. It'll be an RTS core game phase. So that's a forward declaration. Actually, no, I won't have a forward declaration. I'll actually include it. That's our H file. And this will be the game phase state. And I'm going to set a default here, so I'm just going to call it, and it's going to be that loading phase. Yeah, the first phase. So I'm going to create a private section here, and I'm going to put our, I think it has to have a U function on ref. Usually when you're referring to something in a U property, it requires a U function. Look at this. And we can implement that. So what I want this to do is broadcast that the phases change. So we're going to create our first delegate, and we're actually going to pass a parameter. So go up to the H file, and after the definitions here, we're just going to put where multicast delegate, one param. Actually define how many parameters that's in the macro there. All delegate names generally start with a prefix F, just like a struct. So yeah, I'm going to call this on game phase changed delegate. But this is just a name. You can call these delegates whatever you like. I usually prefix the, I always say prefix, suffix, is that right? I can't remember. But I always suffix the name with delegate, so I know the difference between the actual variable for the delegate and the delegate itself. So show you what I mean in a sec. So we're just going to pass a game phase state. So one difference with the multicast delegate is in the definition you don't define you just define the type, you don't name of the variable. So and then down here we want that to be copy that, and I'm actually going to have protected delegates, and then I'll have a public function that's like a getter for the delegate. So I'll just find the delegate here. And then this is what I mean. I'll just take off the F and I change off the delegate, and there's no confusion about what's the variable and what's the actual delegate. It's the same name, you can match it up easy, no confusion. And then in the public section, I'm just going to copy this again. I'll put a description here. This is going to be the delegate getters. It's going to return a reference, and it's going to be, I'm just going to call it the name of the delegate. And I'm going to put it checked. What we're going to do is we're just going to validate that delegate before we return it. So delegate, and we get a reference to the delegate, and then we just put it through check, and that'll cause a breakpoint if it's not okay. So we definitely know that that delegate is valid, and then we can use this to bind to the delegate wherever we need to. So then in our onRep, and broadcast that, and I can pass our game phase state, whatever that is at the current time. It would have just updated as this reps. Oh, we need to add the game phase state to replication as well. Duplicate that. So each time the game phase changes, it's going to broadcast the state out to whoever's listening. So now we're going to have to run some sort of system that checks the state all the time, and if there's any tasks that are outstanding. I think tick's a bit overkill, so what we're going to do is we're going to just set up a timer that starts. So we'll do that in begin play. We want the timer to start straight away, so we're just going to check we are the server. It's the game phase system's only going to run server side. So if we have authority, and then we can start the phase timer. So let's create a function for that. Protected void start game phase. Nice and obvious what that's going to do. Then in the start game phase timer, we're going to check that we have a world reference, because we're going to need to get the time manager. here we're going to need a handle. So let's make that private. Call it, sorry, it's a F timer handle. Call it timer handle timer. Copy that. And it's going to be bound to this object. And we're going to execute a function which we'll just call game phase timer. So this will be the function that's called each tick of the timer, and we'll set the in rate to be, I don't know, half a second, or we could do 1 second. Let's just do it as 1 for now. We can optimize this to whatever works, and then it's going to loop, and we'll put in delay of 1 second at the start. Just so got some other stuff going on in begin play, then time to sort itself out. This automatically changed to start, so I don't want that. I want it just to be game phase timer, and I need to create that function. So in here, we basically want to run a check, should we start the next phase? And if we should start the next phase, so we're going to need a couple of functions for that. So we're going to need should start the next phase and start phase. Implement those. In our phase timer, we're just going to go if should, and I need to change that to return a bool. So this should return a bool. And then if we should start the next phase, we will start the next phase. So now in the should start next phase, this is where we need to check if there's any outstanding tasks for this phase. What we're going to use for tasks is a struct, and we're going to use a GUID as like a reference, like an ID for that task. So let's we'll have a map for that, which will be our reference. So I'm just going to create this first, even though we don't have the struct created. There's going to be a T map. That's going to have a F GUID as the key. So we'll be able to use that to look up a task, like a unique identifier for the task. And then we're going to have F phase registration data. So this is what other classes and things, or anything really that needs to do a task in a phase, this is what it will register. So we'll call this the phase registrations data. Most not big time. So let's create this struct, and we'll go back to our data types, and we'll say uStruct, call it F RTS core phase registration data. So I'm just going to go back. I forgot to add the core in front. Forgot that part. So in this struct, we want to have a reference to the phase that this task is going to be applied to. So that's the game phase. We're going to have we'll just put in some text so we can, it's probably more used for debugging this. So I'm just going to call it text, and this will just be some sort of description of like who's the task belong to and what's it doing, sort of thing. So we can display that in a debug message or something, and then we'll have a bool for whether it's complete or not. I'll call that is good. We want a constructor for this, so I'm gonna have, and we just initialize this, so it'll give us some defaults. So this is a blank constructor, this first one. This will just be, it'll keep it happy. We're going to make this loading. Oops. And we'll just make the text a blank string. Like that. Duplicate this. So this will be a constructor we can use to just pass in all our parameters and have an existing data. So in here, we want to pass a const game phase, and we'll call this in game phase. We want to pass a const f string reference or in text. We want to pass in the, actually no, we don't need to pass in whether it's true or not. We're creating a new task. It's always going to be false, so we can just default it to false, which it's doing. And I think that'll do for that. Let's go back to our game state. And in our should start next phase, we're going to create an iterator over our registration. So let's just put in a comment here. We're going to check if all the registration tasks for a current phase are completed. So we're going to create a constant iterator for on the map we just made. So that's the phase registration data, and we're going to create a const iterator because we're not changing anything. We're just checking. And now we need to check if the game phase that we're checking is the actual current game phase. So if the current .value game phase, so that's reading our struct. So we're reading the struct's game phase. If it's not equal to the current, so we need to have a getter for the current game phase state. So we can make that const. It'll come through. I might put that up here. So it's going to be the RTS core game phase state is what we're going to return, and it's going to get state. Going to be const return game phase. What we're going to use in our function here. So if that's true, then this current registration that we're checking is the current game phase, and then we want to know if it's completed or not. It's going to be the same if the value if it's not completed, we want to return false. That we should not start the next phase is what we were going to return if there's an outstanding task. And as soon as we find one outstanding task, then we can just return false because we don't need to check anymore. But if we get through this whole loop and nothing returns false, then we know there's no outstanding task for the current game phase. In this here, we already know we're changing to the next phase, so we want to increment the phase, and then we're just going to do a check if the phase is valid, because we have like the abort phase, and we may have some others that we don't want to actually automatically transition to. Call them special phases. The abort phase is a special phase. We only want to abort to that if we deliberately say so. We don't want to just in sequence end up in the abort phase. Going to create a next phase in index and the cast of the current phase. And we're just going to add one. So this is going to return the next phase of the current phase, but in 32 format. And then we can run our validation first. So if the next phase index is greater than, it should never be greater than, right? Because abort's the last one, but we're building that in to check. We might have something else there later on. And we're going to cast the abort phase. So we want to know if it's equal to or greater than the abort phase. And if it is, then we've reached the end and we don't want to transition to the abort phase. So so let's create a setter now for our game phase. We'll make that protect. Set game phase. And we're going to pass in if we're trying to go to the abort phase, it means we're at the end, so we're probably coming out of post gameplay. So we want to return to like the main menu or whatever. So let's send it back to load game data. And this is where we could do something different here. We could have the end of the game go somewhere where we have it go back to a lobby or something like that maybe. For now, I just might send it back to new game actually. And if it's not at the abort phase, then we just want to set the phase to the next index. So we're just going to set game phase state, and we're going to cast that int that we calculated to whatever state it's up to. So to set the game phase state, we want to check we have authority to do that. We probably should put that here too, so nothing can start a next phase or something like that. And then here, we just want to check that the phase isn't already the phase that we're passing in, because we don't want to go broadcasting the phase thing again, the phase delegate again if it hasn't changed. That could result in some weird behavior. So we just want to check that the new game phase is not equal to game phase state. And if it isn't, then we want to update it. So game phase state equals new game phase. Now, because this is running on the server, we need to call that on rep manually. Blueprints, you don't need to do that, but in C++ you do. So I'm going to leave this part here. We've got the game phase set up and ticking over. So in the next phase, we'll start implementing our delegates and registering our tasks so we can test our phase setup.